A quick one. Remember, your Jamb examination is fast approaching, and with less than 1 month and a half left to go, it's for you to understand that planning is very key at this crucial stage. We are looking forward to an instance whereby you are strategic in every step of examination preparation you are putting in. And that's why we are here on your study path, bringing in the best of excellence in your goal at achieving over 280 in your UTME examination. Let's get right into it. Today, we are looking at electricity. Our focus is on electricity. Remember, electricity remains a key aspect of your UTME examination with the focus on your AC circuit and your DC circuit. Electricity questions for your UTME examination is a focal point considering your DC circuit in terms of direct current circuit, and your alternating current circuit. That's the two aspects for which they expect you to what? Put in effort into understanding. First and foremost, we get right into your what? Direct current circuit. What are the key highlights of your direct current circuit? It's a focus. Here's it. You're expected to have at the back of your mind that the key element of what UTME examination will be centered on is revolving around physical quantities like number one, resistance. You need to know much things about resistance. Secondly, you need to know certain things that go along with current. You also want to put your mind on voltage. But guess what? The funny thing about voltage is that it comes by different names. Either you're dealing with voltage as a word or you're dealing with potential difference. You get to see them use the word potential difference. Not limited to this, you can also see them use what? Electromotive force. Electromotive force, EMF. So these serve as physical quantities evolving around your voltage. So now you want to get right into understanding these key elements as the first phase of your DC circuit. If these three guys are not coming into collaboration under the questions that you'll be asked, then you'll be having the next set of parameters, physical quantities. Number one, you talk about capacitance. Number two, instead of having current, this time we are going to have charge. And number three, we are going to have your potential difference or voltage. These are the highlights of how we have them combining. So let's get right into it. Resistance happens to be the opposition to the flow of current. And current is actually considering the ratio of your potential difference to resistance. The ratio of the potential difference, which allows what? The movement here. According to Ohm's law, we've always identified that what the potential difference across 2 points is always directly proportional to the current, provided you're having other factors remaining constant. And that's why we said that V is directly proportional to I, and we created the equation that says voltage or potential difference, V equals to IR. The first thing you want to put in mind relating these three guys together. Now, pushing it further, aside having that voltage potential difference, as the name is equal to current times resistance. Have it at the back of your mind that we can have this other guy, electromotive force, EMF. being equal to current multiplied by your big R plus small r. This serves as the second formula to put in mind under this DC circuit. V is equal to IR. Your EMF is equal to the product of current and the combined sum of resistance, such that you're having your big R to be called external resistance. External resistance, and you have your small r to be called internal resistance. A quick one. How do you differentiate between internal resistance and external resistance? A circuit diagram explains better. Having a diagram like this, we can use this to illustrate what your big R would represent and what your small r will represent. Now, have it at the back of your mind that EMF is representing the total voltage possessed by a cell or battery when it is not supplying any current to a given circuit, or when the circuit is open. Note, EMF is actually what? The voltage in a cell or battery when it is not supplying any current to a given circuit. Or in another case, we say when the circuit is open, meaning that current is not flowing through the circuit, completing the circuit. Now, have this at the back of your mind. At this point here, how do we represent cell or battery? We use a long line and a short line. The long line representing a positive terminal, while the short side is representing the negative terminal. Positive terminal, negative terminal. We've identified that what current will always flow from the positive side to the negative side. Current will flow from the positive side and all the way through to the negative side. Then we have a circuit being completed. Put it at the back of your mind that when this cell is actually opened at a given point, in the sense that you don't have your key placed in to allow what current to flow along this path, what you're having is called an EMF. And remember, we say that what you can't have efficiency exactly 100% in the practical situation, meaning that what every cell, the moment you start using it, will always will depreciate in value. Take for example, you buy a battery and you have to place it inside your remote. What you expect is very simple. As long as the nylon is on the body of the battery, no current is supplied. There's no form of discharge happening. So as such, the moment you tear off the nylon and you use it, you have maximum voltage being supplied to the circuit. But the moment you have it connected, wires connected around it or placed into the remote, you have the voltage start dropping. The same thing applies to our cars. A brand new car is all serving and you have the efficiency perfect. A further use of the car drops it. And that's where your internal resistance come in. Note, we never label internal resistance along our circuit. Guess where you are going to find your internal resistance? Exactly at this position. Once you're having your battery value, you'll be giving your internal resistance along with it. Your internal resistance is always labeled alongside with the EMF. So watch out for your internal resistance located close to the cell or battery. Located close to the cell or battery. What's the difference between a cell and a battery? Cell, a single long line and a single short line. You have your cell. The moment you're having multiple, two or more cells, then you're talking about a battery. So positive, negative, positive, negative, positive, negative. You have this as a battery, but a single positive and negative terminal, then you are talking about a cell. You might be wondering, Why does this man have to go through all this? Yes, Mr. Femi has to mention all these aspects for us to drive home a point as to what to expect in your examination. You should never mix up internal resistance and external resistance together. Please, never. There are guidelines of calculating the effective resistance you are going to have in a circuit. Whenever there are many resistance present, you should calculate all the external resistance represented by capital letter R. Note, external resistance, capital letter R. There are two patterns to determine your external resistance. We say series connection. Whenever we have series connection, the effective resistance in series is equal to R1 plus R2 plus R3 among other resistance given. But the moment you're having parallel connection, for parallel connection, 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, if you fall under the category of students that would actually go ahead, for example, you are given values 2 ohms as the value of resistance here, and you have 3 values. Please don't do something like this. R1 happens to be 2 ohms, R2 happens to be 2 ohms, R3 happens to be 2 ohms. Then you go 1 over R parallel, 1 over 2 plus 1 over 2 plus 1 over 2 equal to 1 plus 1 plus 1. Then you write 3. 2 plus 2 plus 2. Then you write 6. You're going to fail it woefully. I'm talking from experience. If you are above this level, congratulations. But if you still fall within the bracket of people that will go this way, then you fail your Jamb woefully. It's easy to pass physics and it's very difficult to also pass if you don't know certain guiding principles. Endeavor to find your LCM. What governs this approach is simple LCM. At this stage, take the LCM as being 2. 2 will go inside 2, 1. 1 times 1 is 1 here. 2 will go inside 2, 1, and you have 1 here. 2 will go inside 2, 1 times 1, 1, leaving us with 3 over 2. Even at this point, we cannot say 3 over 2 is the final answer. We don't divide and pick 1.5. What we simply do is cross multiply, and you're going to have 3 RP being equal to 2 here. Dividing both sides by 3 leaves us with RP equals to 2 over 3. And that will be 0.667 approximately. Calculating resistance in series, resistance in parallel. If you are given a cell, what is supplied, as long as internal resistance is not mentioned, please stick with Ohm's law. I come again. As long as the question in your UTME past question is not related to internal resistance, small letter R, please stick with Ohm's law. The moment you have that word internal resistance is mentioned, then you work with EMF being equal to current into bracket external resistance plus internal resistance. So let's push forward. All this being said, let's look at questions now. What are some of the questions you expect to see? A simple one as this. Questions. Three ohms. 2 ohms. 2 ohms. Then you have 4 ohms. Now, having a question like this, you want to ask yourself, how do we combine all this resistance into becoming just one resistance? That's the job you have to do based on what we have here. Combining all the resistance into just one. How do we go about a question like this? It's first for you to identify which is in series, which is in parallel, which is in series, which is in parallel. That's the focus. What you have to do first, identify which one is in series and which one is in parallel. To do that, very easy. Whenever you have a circuit, there's always a path through which your circuit will flow. In this instance, if we have the circuit flowing in this direction, you are going to have current entering the first resistance, which is 3 ohms. So as not to mess up our diagram, original diagram, I'll redraw it here. Three ohms is here, 4 ohms, 2 ohms, 2 ohms. We have that whenever current is to flow from here, the current gets to enter into the 3 ohms. When it gets into this, at this junction or point, it tends to split. Note, it tends to split. On splitting, some of the current will move further along this path, some will move downwards. How do we identify series? If the current has to move and it does not, any junction it gets, it has only one turning point, then you have a series connection. The moment you have 2 points to turn to, then you're having a parallel connection. Now, these 3 ohms, you have a series connection because it's entering the 3 ohms, coming out. When it gets to this junction, it has to split into 2 parts, some moving down, some moving along this right side. You are going to have that what this guy is in parallel with this guy parallel. You have that your 2 ohms here is in parallel with what? The 2 ohms here. How do I know? Current flowing through the 3 ohms, getting to this junction, has to split. When it splits, at the end of the day, having passed through the 2 ohms down to this point, both of them join together in order to continue before entering your 4 ohms. As such, 2 ohms here, 2 ohms here are in parallel. I come again. Why? They are splitting. The current flowing here tends to split at this junction. Very key. So, how do we solve this? We have series here because when they join together, the whole total current is what will flow. Here, you have series here because the original current supplied will enter the 3 ohms without splitting at any point. It is just at this point you have the splitting of currents. Parallel connection. We say 1 over R parallel should be equal to 1 over 2 plus 1 over 2. When we have this LCM, we say the LCM is 2. 2 will go into 2 and 1, 1 multiplied by 1, 1, plus 2 will go into 1, then multiply by 1, you have this. Easily we can say that what? Your 1 over RP is equal to 2 over 2. We know that cross multiplying will be having 2RP to be equal to 2. Dividing both sides by 2, RP equals 1 ohm. So it means merging these two resistance together, you are going to have something like this. Your 3 ohms. Instead of having two resistance effect at this point, you are just going to have only a single resistance, 1 ohm, because the 2 ohms and the 2 ohms, the combined resistance supplied is 1 ohm. These 2 ohm and 2 ohm in parallel, you're having the effective resistance as 1 ohm. Now observe, when current is flowing here now, it's going to be in series. Current enter this part, series, and you have that what? At this part, you're going to have a series connection. Guess what? You don't have to think twice while you are actually what? Calculating this. Simply because in series, it is a direct additive instance. A direct additive instance. Current will flow When it gets to this junction, it has only a single route to turn, and it means it is going to turn downwards. Turning downwards here, it gets to this junction as well. There's only a single route for the current to turn, and that's what moving towards this direction. And entering into the 4 ohms, it tends to what? Exit. So current flows here, 3 ohms resistance receives the current exits out, gets to this junction, it turns down. There's only one direction to turn. And we have that the parallel instance has been taken care of. Now we have series connection. 3 resistance we are going to consider. The first, second, and third. We say that our series is going to be 3 plus 1 plus 4, and that will give us 8 ohms. It means the combined resistance at the end of the day is going to be what? 8 ohms. Guess what? The options provided for us here, you have the 8 ohms, you have 4 ohms, 6 ohms, 1 ohm. So don't be tempted into picking 1 ohm. That would not be correct. Don't be tempted into picking 1 ohm. That would not be correct because you just found a single instance. And please, they have played so much with the intelligence of students over the years, considering when Jamb was in existence. This year now, 2025, you'll be talking about, once you write this examination, you'll be talking about having used about 37 years. Jamb in existence for over 37 years. For 37 years. Now, this is the catch. Okay, sorry, 11 ohms here. Now, what is the trick they are playing on you? They know that some students are so just lazy to put in effort. Someone can just say 3 plus 4 is 7, 7 plus 2, 9, 9 plus 2, 11. Let's go for 11, and they are good to go. And you get to fail it. Some will say, why stressing myself? I know that 2 and 2 here is 4. Maybe 4 is here, 4 is here. They are looking at the bigger number and they go ahead picking 4. Some will even say, how about they are just playing trick on me? 4 plus 2 is 6. 3 times 2 is 6. Therefore, 6 is the answer. You are going to fail it. While some will say, oh, maybe this 3 is not just there. Maybe it's just an instance of 4 plus 2 plus 2. That's how they got 8. Please, they've devised ways of knowing what thoughts can come into your mind as a student. And they structure their answers based on certain tricks as to what you can think. Oh, if I'm going to do maybe this plus this minus this, they've actually considered all that. And please, 11 cannot be, because this is the most tempting. 4 and 6 might still require some reasoning. We don't have using all the numbers to arrive at 4 and 6. But 11, oh, once I add all of them together, straight up, I have my 11. You are going to fail it. Put in mind, series connection and parallel connection. These two guys are parallel. These two guys are in series. But the moment we merge two parallel together, you have a series connection as a result. And that's what I've shown you. Please note, this is not the answer. This is the correct answer. 8 ohms. 8 ohms. Another question is now popping up with regards to capacitance. In the same year, we want to calculate capacitance in the same year. Where is it? Yes. So for the same year now, let's see what we are going to have talking about a connection such as this. Permit me to say that in the instance of capacitance, we have a twist in the arrangement. I have given you the voltage value. I have given you the EMF formula. For capacitance, we said that capacitance in series connection for capacitance in series. And please, this is the symbol for capacitance, farad. Or you might see them use microfarad most times. You have the capacitance in series. We use 1 over capacitance in series should be equal to 1 over C1 plus 1 over C2 depending on how many capacitance we are given.